am from the Indian Institute of Astrophysics. We are a research institution based in Bangalore and Koramangala. How many of you heard of us? Cool. So we were established as an institute under the Government of India in 1971, but then we trace our origins back to 1792 with the Madras Observatory set up by the British. And in 1899, Madras Observatory was closed and moved to Kodaikanal to function as a solar observatory, and that is still functioning. It became IIA, and we are celebrating the 125th anniversary of the Kodaikanal Solar Observatory this year. So we are a fairly old institution dating back to more than 200 years. We have our headquarters in Bangalore, where we have more than 50 astronomers as faculty working, doing research. We have around 70, 80 students doing PhD or masters. We have more than 100 engineers, and we need more than 100 engineers because we run four observatories. We have an observatory in Kavalur in Tamil Nadu, in Kodaikanal in Tamil Nadu. Both of them are optical. There's a radio observatory in Gauribidanur, which is just north of Bangalore, and we also run a very well-known observatory in Hanle in Ladakh, which you might have heard about, right? In addition, we have a technology center called CREST in Hoskote, which is again near Bangalore, where we do two things. One is we make space payloads. So we made two space payloads which are functioning right now. One is called the one is called the UVIT, the Ultraviolet Imaging Telescope on Astrosat, which is around 8 years old and still in space. The second is the Visible Emission Line Coronagraph, which was launched on Aditya L1 last year. Have you heard of Aditya L1? It was launched a week after Chandrayaan's landing, right? It's a solar space mission. And apart from making space payloads, the Hoskote Center also grinds and polishes mirrors for an international telescope to be built in Hawaii called the 30-meter telescope, of which India is a member. Okay, so there's a little bit about us. COSMOS is a project of the Indian Institute of Astrophysics with University of Mysuru. It's going to be the world's first LED dome, fully LED dome planetarium, and it will be functional sometime in the beginning of next year. But as Amog said, we have already started outreach programs, and Amogosha and Puneet and now Sumukha have been very, very active for more than a year now. They conduct at least one public event a week. So if you're not involved in it already, you should be. And the way to get to know more about events in Mysore is for you to take your phones out now and then join the WhatsApp group. I think some of you have done it already. Others can do that right now. This is a admin post only WhatsApp group where you'll get information about events in Mysore by IIA Cosmos project. Okay. Have you all done it? Then I'll move on to the next QR code. Done? Yeah? Okay. I see some uniforms here. Where are you from? It's a PU or undergrad? Sorry? Undergraduate. Okay. Which discipline are you all in? Physics. Oh, great. Fantastic. Okay. The next one is a QR code for an free Android app on Zero Shadow Day. It was developed many years ago by the Astronomical Society of India. I would also urge you to download this app now. It's free. You can delete it after a week or so. It has a lot of really fun visualizations, animations, and information, and we will be using this app today. So please do download this as well. Done? Okay. The third is a WhatsApp group for the Indian Institute of Astrophysics itself. So this has a bit more information about ongoing events, current events, and so on. This is posted from Bangalore, so you can join this group as well. This is also an admin post only group. Everything is stretched out a bit on the screen horizontally, so you don't mind that. Done? Okay, so let's move on. It's 2022, so I'll finish by 11:30. We'll be done maximum. Okay, right. So my name is Neeraj. I work in IIA. I'm the head of the outreach section. Vikrant there works with me in Bangalore, and it was formed 2 years ago. And we do a lot of public programs, both in person and online. We also create a lot of resource material and make it available for the public in many languages. So I hope you've seen some of them before. If not, you'll see them in the WhatsApp group. Okay. So the first question is, where does the sun rise? There'll be a lot of questions, and if you don't answer, I won't move on. So where does the sun rise? Huh? East. Where does the sun set? Does it rise at the same point every day? Does it rise exactly at east every day? Yes or no? Who all say yes? Who all say no? Why no? Why doesn't it? I thought when I was in school, I was told it rises in the east, sets in the west. How come all of you know that it's not true? What happens instead? You're right. It does not set in the east, rise in the east, set in the west exactly. So what happens instead? Yeah. Do all agree? Is that something you all know? No, it doesn't rise exactly the east, but you're not sure exactly why. Right? Okay, good. Good. That's why you're here. So on the left here, you see a photo taken from Pune, okay, by an amateur astronomer. Oh, good. So on this is the sunset location from a terrace. Okay. So you can see very clear on 7th June, 10th May, 19th April, 15th March, right? As the so 15th March, April, May, June. You can see the sun does not set at the same location, right? It's very clear, right? On the right side, you see a similar set of photos taken from I think Finland, where the from top to bottom is goes from January to February, and again this is the sunrise, I think, and you can see not only does it keep going from left to right here, so it goes from right to left, but then it goes back to left, right? Back to the right, right? So that's obvious because after a year it has to repeat, right? So clearly the sun is doing something very funny. Now, therefore it doesn't rise exactly in the east, it rises slightly north of east and then slowly comes towards the east, then rises slowly south of east and then comes back in 12 months to the same position, right? Why 12 months? Because we go around the sun once in a year. Okay. So the answer is clearly no. This is clear to everybody. We don't know yet why, but we know this happens. Correct? Okay. Now to for that, so there's Harding Circle, which is all of you know Harding Circle in Mysore. This is now if you look at this is the if you stand in at Harding Circle where the statue is, this is the direction of sunrise today. Okay, and there is a sunset today. So what you notice first, it's not exactly east-west, right? Second thing you notice that the two lines don't make 180 degrees; they make an angle, right? So it's not that the sun rises here and sets exactly opposite from you. It rises here and then sets here, not here, right? It makes an angle. That's one thing you notice, right? So that's funny. Now this is the same Harding Circle sunrise sunset on spring equinox, June 22nd June solstice, 23rd September autumn equinox, and 22nd December winter solstice. These 4 days you all know. You read about it in seasons in geography class or something, right? So now you see what's happening here. During 21st March and 23rd September, it actually rises exactly horizontal, exactly east and sets exactly west, making 180 degrees. Right? Why? What's special about these 2 days that it doesn't? Do you know? The clue is in the word spring and autumn. Right? That's when spring and autumn start. We'll look at why. Equinox means equal time. Okay, as equal time because on these 2 days, the day and night are roughly equal duration. Okay, that's why. Now but then on summer, 22nd June is supposed to be the peak summer, right? According to Europeans, but according to India, it's not. Mysore, the peak summer is today because sun is going to be directly overhead Mysore today, right? It's going to be really hot. So here you see sun rises here, sets here, north of east-west line, right? And on 22nd December, which is supposed to be the coldest for again Europe, it rises here and sets here south of the east-west line, right? Now you can do that yourself. So at some point, you have your terrace or you have your school building or college building. Just note if you get up very early, which I don't, or in the evening during sunset, just check every few weeks, just see where the sun is rising. And it's a nice school project for you to do as well, right? You can do a project where you draw the outline of your western horizon as seen from your terrace, and then every 2 weeks you mark the portion of sunset, and then you'll see this north-south motion, right? And then you can show it in school or college, and then you get great marks. Okay, so second question, where is the sun at noon? Other answers? I need answers from More than 1%. Where is the sun at noon? In general, he says above your head. Okay. You all agree? Above your head? Okay. It is directly overhead? The answer is no, it's not. Okay. Now, it's not directly overhead. It's overhead. Now, how are seasons caused? It's hot in summer, cold in winter. Why is it hot in summer and cold in winter? No, that's what many people read. That's not correct. That is partly true, but there's a very, very small effect. There's a much larger effect which makes it hot in summer and cold in winter. In fact, the Earth is farthest away from the sun during around June, okay, where it should be the coldest, right? At least for the northern hemisphere, right? So that's a very small effect. That's correct, but it's a very small effect. It's a much larger effect as to why is it hot in summer, cold in winter. All this we read in 8th class or 7th class. You all forgot what you read. It's hot in summer and cold in winter. That you agree? Why? When is it hot for us? April, May, June. Is it hot for Australia at the same months? When is it hot in Australia? End of the year, right? November, December, January is hottest in Australia. Why? Does that give you a clue? But both face towards the sun. But there's something special about the way the northern hemisphere faces the sun in April, May versus November, December, January. What is it? Do you know? So it's all linked to this number 23.5, right? So before we go there, so sun does not rise directly overhead throughout the year every day. Okay, it does not. If it is, then it will be zero shadow day every day, right? It's only today we're saying zero shadow day, right? So for in winter, so the sun will rise, and then the highest elevation the sun will take will be quite low. Okay, so the highest the sun will get in winter will be around this much. Okay, in summer, the highest it will get is much larger angle, right? So it will be higher in the sky in summer than winter. Okay, is that familiar? Is that something you heard before or know before? No? Okay. In winter, if you notice, the sun does not get as high as it does in summer. Okay, so this is something we can observe, right? So this is a very nice photograph, very famous photograph taken from Hungary by this guy. What he did was he made a pinhole camera. You all made a pinhole camera in school? All of you did pinhole camera in school? How many of you don't know what a pinhole camera is? You will get to know soon. Pinhole camera is you have a box, closed box, and then one end you put a small hole, okay, and then the image of what's outside will be formed on the screen opposite inside the box. Okay, that's a pinhole camera. He put a photographic film on a pinhole camera at the other end. He exposed it every day for a whole year, okay, towards the sun, towards the south, because Hungary is north. Okay, so what he found was, so then he can see the sun continuously. It's not overexposed because the pinhole camera and the film is not that sensitive. So you could actually see the sun throughout the day and then nothing happened to the film. So this is the track in winter. On 21st December, this was a track of the sun. This is the actual track of the sun, right? Every day he made the track. And then in 21st June, this was the track. So look at how high the sun rises, right? In winter, from Hungary is around 40 degrees, 48, not 488, 48.8 degrees latitude, 50 degrees latitude. In winter, the highest the sun got in the sky is only this much, right? Like that much, right? In summer, it got up to there, right? And you can see, and then the middle, March, September, it was somewhere here, right? So you can see this photograph that the highest the sun rises changes throughout the year. It does not get very high in winter. It gets much higher in summer, and that is why it's hot in summer and cold in winter. Okay. Now let's do some more basics. It's all geography. This is not astronomy. Today is all about geography. Okay. Now, how do we define north, south, east, west? on Earth? This all of you know, right? This is a globe. How do you define north, south, east, west? Directions on in the horizon here. Standing here, how do I define north, south, east? I said sun doesn't rise on the east exactly, doesn't rise on the set to the west directly. But how do I know what is east, what is west? I have defined it somehow, right? You define east and west based on north and south. So how do you define north and south? I'm not generally doing this because I have anxiety. I'm doing this as a clue. The Earth rotates around its axis once every, how long does it take for the Earth to rotate around its axis? 24 hours, right? It rotates like this, right? It rotates around an axis passing through its center, obviously, like a ball, right? And so if you join so therefore the line joining the north pole, center and south pole is the axis of rotation, right? And that defines north and south, right? So if I'm standing from here, I know how the stars move, right? And therefore I know what is the axis of rotation direction around which the stars move every day, and therefore I define north and south. Once I define north and south, then I say the perpendicular line is east and west, correct? That's how we define north, south, east, west. Okay. And so what is if this is the axis of rotation, then you can draw a line perpendicular to it at right angles at 90 degrees to it, right? That line, it lies in the plane of the equator, right? That's how we define equator. Equator is the line on the surface of the Earth, which is a midway between the North Pole and South Pole, correct? All this is basic, but then we'll go through all of them because you all forgotten your geography. Okay. Now, how do you find a location on Earth? If you want to tell somebody go somewhere in the middle of the ocean, there's buried treasure. How do I tell them where to go? Answer is here. You read it out. Latitude and longitude, right? So that's a grid of coordinates I use to find define a particular location on the surface of the Earth. So how do I define latitude and longitude? Have you done latitude and longitude in school yet? You have not. Both of you have not. Okay, now you can learn and go back and tell them. So how do you define latitude and longitude? Have you seen a graph paper? Yeah? So graph paper, how do you define a point in the graph paper? You draw x-axis, y-axis, right? And then you mark 1, 2, 3, 4 in x-axis, 1, 2, 3, 4 y-axis. Some point you find out what its x-axis distance is, y-axis distance is, and then you say x and y coordinate. Correct? Same way, you can wrap the graph paper on the Earth, let's assume. So then that's called the latitude longitude system. Okay, that's for them. For you have to give me a better answer than that. So how do you define latitude and longitude? Here, which is this? This is latitude or longitude? These circles. Latitude circles. These circles are longitude circles. What is 0 latitude? Louder. Equator. And we know how to define the equator. Equator is the line on the Earth which is exactly halfway between North and South Pole. So that's 0 latitude, right? What is the latitude of the North Pole? Huh? 90 degree north. And latitude of the South Pole? 90 degree south, right? So this is all new to you. You are very quiet. If I had to slow down, repeat something, you have to tell me. Because I'll use all of this to go to zero shadow. It's clear. If not, you have to tell me. Okay. So this is the North Pole and South Pole. The mid line is equator. That's 0 degrees. This is 90 north, 90 south. And therefore, this will be 45, 30, 45, 60, and so on. Right? So I define latitudes moving this way. Right? Actually, is the angle between the center of the Earth and the point here, but that we will ignore for now. Right? And therefore, this is 0. This is 10, 20, 30, 40, 50, 60, 70, 80, 90. Same way, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay? So which is more north? Us or like London or Paris? London, which means it's closer to the North Pole or farther from the North Pole compared to us? closer. What about Australia? It's in the southern hemisphere, right? So its latitude is how much? Roughly 40 degrees or so south, right? So here if you look, there's Australia here and there's India here. So India is around, let's say 30 degree north, Australia is 30 degrees south. It's exactly opposite side of the equator. So that's latitude, right? Now if I know but then the latitude goes all around, so I need to know in this line, where am I on this line? So I'll say Mysuru is at what, 11, 12 degree latitude. That is this line going here. But along this line I can be anywhere. So I have to say, where am I? So that is given by longitude, right? So then I connect North Pole and South Pole, and then I connect like this, multiple lines. Those are the longitude lines here, right? So from North Pole to South Pole, North Pole to South Pole. So from North Pole to South Pole, I can draw any number of lines, right? I can draw from here, from here, from here. I can draw infinite number of lines. They're all longitude lines, right? Now for latitude, what is the zero? Equator. So equator is there, so it's obvious that we use equator zero. It's convenient to use equator zero. I could have chosen zero as latitude line passing through Mysore. It's okay. Then the North Pole would be 79 degrees, and then the other one would be 112 degrees. But that's all right. But then we chose the equator to be zero because it's convenient. It's a very convenient and obvious system. Now for longitude, I need a zero, right? So is there an obvious longitude where it is zero? Like the equator, is there an obvious longitude which I say is obviously zero? Huh? But why is it obvious that it's Greenwich meridian? Equator is independent of what country, politics, etc. Greenwich meridian, why was it chosen? Why do you think Greenwich meridian is, the longitude passing through Greenwich meridian is 0 degrees longitude? What do others think? I'll come down here and make you answer. Why do you think that the longitude passing through Greenwich meridian in England is 0? Is there an astronomical or geographical reason for it? What do you think? Try to give me some answer. I am moving from there. So what do you think? Yes, you have to guess. Everybody's supposed to guess. You don't time travel. You don't move backward. Then it's very easy. Then I can go, I can have breakfast every day by just moving backwards. Every hour I can have breakfast. Right? Time doesn't travel. No, I'm asking you a different question. I'm asking you, why is zero longitude going through Greenwich in London? Is there a geography answer? Is there like obvious scientific reason for that? Just like the equator is zero latitude. What do you think? You know that it goes through Greenwich meridian. 0 degrees Greenwich meridian, that you know, right? So then, and we are how many hours away from Greenwich meridian? You know that? Our time zone is, what is our time zone? So we are 5.5 hours before Greenwich time. You know that? Do you know that? In your phone, you have to put time zone, or you have to tell it to get time zone on its own. Have you seen that? In watches also, you have to say time zone. If you go to a different country, you have to change your watch. Why do you have to change your watch? Why do you have to change your watch when you go to a different country? You think? Even if you go to Nepal, you have to change your watch. Why? But so what? Why should you change your watch? Why do you think you have to change your watch? But why? Why? But why? You're giving me the same answer in multiple ways. But why? Why do you have to change your watch if you go to a different country?
There's some Greenwich meridian time That's a reference point from where.
Yes, but why do you have to change your watch? Why is the time different in every country? We have one time zone, 5.5 hours away from Greenwich. Russia has 11 time zones. US has 6 time zones. Why? Why should Russia have 11 time zones in one country? It's vast, but how vast? Chile also is very big. Chile has only one time zone. What is the difference between Chile and Russia? They're both big, but they're big in different ways. What's the different? I want to ask them. They have to answer. They're not answering. I'll come back to you. Yeah, here, this group and this group. You're all very, very quiet. So tell me, why do you have to change your watch? Why is the time different in different countries? Yeah, so what? So what? Bombay and Guwahati also have a distance between them, very large distance. Do you change your watch when you go from Bombay to Guwahati or Calcutta? You don't. But then why do you have to go? In Russia, the 11 times. If you go from Moscow to Vladivostok, you have to change your watch 11 times. They are on different longitudes. But why? 12, roughly 12 is 12 noon, right? So 12, if you have to change your watch, what will happen to 12 noon? If I'm in Moscow, right, and I have a watch, and I have a watch in the, and the other person is sitting in the easternmost part of Russia, right? So Russia is, so they in Moscow, somebody sitting in Moscow, and then somebody sitting here, eastern part of Russia, okay? So there are 11 time zones between them, roughly of 1 hour each, okay? Which means if it here is 12 noon, what's the time here? Huh? Tell me. What is the time here? If it's 12 noon here, what will be the time 11 time zones away? Yes, I want some answer, yeah. Come on. You don't want to get away by keeping quiet. What if it is 12 noon here? What is the time 11 time zones away? Jidam, I want to know your answer. What do you think? You can look at the globe. See, take it.
Yes, sir. Yes, 11.
Plus 11. So what is it? 11 p.m., right? Huh? But why? Why 11 p.m. means night, almost midnight, right? So if it is 12, it's noon here, it's almost midnight here. Why is that? Is that true? Is it sensible? Does it make sense? Why does it make sense to you? Yeah. Uneven is not mean. Do you think it's uneven for at midnight? The earth, the basic answer is the earth is round, right? If the earth is flat, would you have different times in different places? No, earth is round, right? And the light of the sun is light on earth is coming from the sun very far away, right? And therefore, supposing the sun is there, okay, let's go to basics. Sun is there, okay? I am here in New York. What is the time here? I'm rotating this way, right? I'm rotating west to east. Earth rotates east to west or west to east? West to east. That's why the sky rotates east to west, right? So it rotates west to east like that. So if the sun is there and New York is here, what time is New York? What do you think? You say 12 noon. What do you say? Huh? What time roughly? What's happening here? Exactly here. Rising. Sun is rising? Okay. Now what's happening in Europe? What's happening in Europe? Europe is here. Sun is there. Huh? Noon. The sun is pointing towards the sun, so it's noon. And what about here, Thailand? What's happening in Thailand here? Sun is setting, right? Because sun is there, and then this was noon already. That was gone here. So Thailand, sun is setting. What's happening in the middle of the Pacific Ocean? Midnight, correct? So time does change across because the earth is round and the light is coming from the sun very far away. Time keeps changing. So if you have Russia here, Moscow, sun is rising. Vladivostok, sun is setting. Sun is there. Sun is overhead, noon, almost overhead, at high, very high, right? So that's why there's around 11 time zones between this and this. Now, longitude, let's back to the original question. Our longitude 0 is through England, to Greenwich. That's only because the British colonized the world. That's all. That's a very simple reason. Yes, one of you said it. It's just politics, right? So the French also colonized the world. So the French had their own longitude system which passed through Paris. They both had a huge fight about it. Then they all agreed that we'll follow British because the British were more powerful than the French. That's all. Now, India has had a long tradition of astronomy calculations. Right? What did we use? Did we use Greenwich meridian as 0 to calculate 1000 years ago? No, we didn't know about London at all. What was the 0 meridian for India? Do you know? Traditionally, for the last 2000 years, at least 1700, 600 years, 700 years, what was the 0 longitude for Indian calculation in astronomy? The longitude passing through Ujjain. Okay, I say Ujjain is important. And that's also why there was a Jantar Mantar in Ujjain later. So longitude passing through Ujjain was 0 degree, well, Dongra, which is right near Ujjain, was 0 degrees, and also it's near 23.5 Tropic of Cancer. That's why it is chosen long back as a 0 point for calculations in Indian system of astronomy. So longitude 0 is completely political. Okay, latitude 0 is not. I think I'm slowing down. I should go faster. But if you don't understand this, you won't understand what comes later. So it's okay to go through all of this. Okay. And then I'll send you an online quiz tomorrow. Right. So we all of you said Earth's axis is inclined at what angle? Earth's axis is inclined this. All of you studied in school. Yeah, come on. Huh? 23.5? 23.5 number is familiar. Have you heard of it? Have you heard of it? No, yes. How many of you haven't heard of 23.5 degrees? You never heard of 23.5. You guys at the back? Have you heard of 23.5 degrees? What is it? You heard of 23.5? Fantastic. What is it? Is the angle of the rotation axis of the Earth. Right? Is the axial tilt of Earth's axis 23.5. Now for angle, you need two lines. Right? If you have two lines like this, the angle between them. So the 23.5 angle, one line is the Earth's axis of rotation. What is the other line? Huh? 0 longitude comes from North Pole to South Pole. Now, if we say, now, I mean, is the Earth like this or like this? Like this or like this? This. Why is it like this? Then it will stand on the table. But then why have you made it? Why have you put this here? Because the angle made by this line and the vertical is what?
Perpendicular to the rotation of the Earth.
On others. Angle made between this line and this is 23.5. What is this line? How do you define this line? How do you define this line? What is this line? Here, what is this line? I made with my hand. What am I showing? What? What is this line? What is this line? For us in this hall, what is this line? What is this line? Horizontal, vertical. What is vertical? How do you define vertical? If you drop a stone, what happens? How will it fall? So how will it fall? It will go here, it will go here, where it will go? Downwards. The path taken by a stone, if I drop it, is defined as the vertical. But that is for Mysore, right? So there is no, but then in space, there is no vertical, horizontal, up, down, left, right, nothing, right? So how do you define this vertical? And I can't put a table in space and say I put it here, therefore I define vertical. So 23.5 degrees is the angle between the axis of rotation and what? So Earth goes around the Sun in an orbit, right? That orbit defines a plane, right? You can draw a perpendicular to that plane, right? That's the axis of revolution of the Earth around the Sun. The angle made between the axis of rotation of the Earth and the axis of revolution of the Earth around the Sun is 23.5 degrees. Okay, that is why We put it on the table like this. Okay, so that angle is 23.5 degrees. It could be anything. For the Earth, it's 23.5. Okay, so for other planets, it's different. Okay, now once we know this, then 0 degree is equator. 23.5 degree latitude we define as Tropic of Cancer. 23.5 degree south we define as Tropic of Capricorn. And South Pole, North Pole. Fine. And then Arctic Circle is 66 degrees. Why? 23 double. Right? Or 23 from here, sorry, 23 from here 60 degrees and 23 from here 60 degrees. So that's the Arctic Circle and Antarctic Circle. Correct? Okay. Now, next question. Why do we have seasons? All of this is just geography. Right? Why do we have seasons? The electricity is a very small reason. The main reason why we have seasons on Earth. All the answers to my questions are on the slide only. You have to look at the slide and tell me. Why do we have seasons? Huh? Yeah, so the Earth goes around the sun, it revolves around the sun. Then you have summer, spring, summer, autumn, winter. Why? We also said we already know summer it's hot. And we already know in summer the Earth comes, the sun goes higher up in the sky than winter. So if it goes higher up in the sky, why is it hotter? Now we move from geography to geometry. If the sun is higher up in the sky, it's hotter because that's summer. But why is it hotter if it's higher up in the sky than lower in the sky? Sun is roughly same distance from us, high or low. Nah? It's just angle. Actual distance is roughly same. No, I want, okay, you tell me the end. You tell me the end. I want other answers, then we'll come to you. Okay. Why do you think so? Seasons you're done in school? You're done in school, right? How many of you are like 8th class, 7th class? 9th? Which class are you in? 10th. Ah, okay. Then you should know this. So, why are seasons cost? Why is it hotter in summer for us? No, that's not. So, that is a very small effect. That's not the actual full main answer is something else. What is that? See, I'm telling you, the clue is that in summer, the sun goes higher up in the sky. In winter, it doesn't go as high up. But why does that lead to it being hotter? If I put a bulb here or here, I get the same amount of brightness. I get the same amount of heat. But then for the sun, it's not like that. No. Why? Yeah, you're getting there. You're getting to the answer. It's tilted, and so when the rays fall on the Earth's surface, what happens? What's the difference between the sun rays coming from there and here? Okay. So you want to complete the answer? What? No. In winter, it's just lower the horizon. It's above the horizon in daytime. Nah? Yeah, so what? Yeah, but that's not the main reason again. Correct, but that's not the main reason why it's hotter or cold. Correct, you're right. That leads to a different, usually that effect you see more during sunset and sunrise, what you're saying. But then you are getting there, no? This figure you all know, no? We all do this figure for 5 marks in school, no? Correct? Draw the figure for seasons and mark the season time. All this you drew, then you all forgot what it was. Okay, the Earth's axis is tilted with respect to the revolution axis, that we know. Okay, now the reason we have seasons is not because it's far away or closer or whatever. It's because when the sun is higher up in the sky, it falls over a smaller area. The same amount of energy is over a smaller area. Okay, therefore the energy per unit area is high. If the sun is coming from an angle, the same amount of energy is falling over a larger area. Therefore, for a given unit area, the amount of energy falling on it is less. That is the reason why you have seasons. That is the reason why it's hotter in summer and colder in winter. Because the amount of energy received from the sun per, let's say, over this table, the sun is here, then the amount of energy received by this table is far more than the sun is coming at a slanting angle. That is the reason. Is it clear? Does it make sense to you? Yeah. Now a very, very small factor is the distance, like you said, but that's a very small factor. This is the biggest factor. Okay. So therefore, now we'll get to zero shadow day. Okay, slowly. Now the sun, this is not to scale. Clearly, the Earth, sun and Earth are this close, will all fry. This is not obviously to scale. Okay, but now we know that the sun, this is the plane of the orbit of the Earth. Okay, so the axis of revolution is exactly vertical, and the axis of rotation makes an angle of 23.5. Epsilon is, this angle is 23.5 degrees, the famous angle. Okay, now this is the equator. Equator therefore points downwards here, upwards here in this case, right? Tropic of Cancer, Tropic of Capricorn. Now Tropic of Cancer is 23.5 degrees north, because this is also 23.5 degrees away. Okay, now what happens here? Now sun is direct. Now we know that, here is sunrise. For a point here is midday. Then the point exactly behind this is sunset, and the point here is midnight. Correct? That we know. Yes or no? Yeah. Okay. Now what about this way? What about a point here, point here, point here, point here, etc. Now among these, which point is pointing to the sun directly? For which point, if you're standing here, sun will be directly overhead. From here to here, if you look at the other point, supposing, can you give me some small thing? Okay, so this is the person. Okay, head is here, foot is here. Okay, head, foot. Now, can somebody come here? Somebody, okay, you come here. No, you're 9th class, no? Perfect. Come. So this is the head, this is the foot. Okay, head, foot. Okay, now this is head, foot. Now at the pole, how is this person standing? Is this person standing like this, like this? How is the person standing?
Like this.
The pole?
Yes. Like this.
No. You have to stand. This is the center of the earth.
Yes.
So will it be standing like this, like this, like this, like this, like this? How is it standing? Point it there.
Like this.
Why?
Because the earth is still.
No, but you're here. You're standing here, na?
Yes.
So then what is the tangent to the circle? The tangent to the circle is here, right? So you'll be standing like this, right? So for you, up is here, down is always towards the center of the earth, because down is defined by how does a stone fall, right? Stone falls towards center of the earth, always, right? And therefore the direction towards center of the earth is down. The other direction is up. Your foot is down, head is up. Now tell me, therefore this is, foot is down towards the earth, head is up. Okay, now for the equator, how will it be? Now for the equator, this point, right? Now where will the foot be? Towards center of the earth. So can you place it there and tell me? If a person is standing here, right, this is the foot. Foot has to point towards where? Towards center of the earth, right? Now can you place it so that the foot points towards center of the earth? Exactly. Correct? So for a person standing here, this will be the head, this will be the foot. The foot has to point towards the earth center. So if a stone is dropped here, stone will move towards the earth center. If a stone is dropped here, it will move towards the earth center. Now what about a midpoint here? Let's see. So this is here, this one is here. What about this point? Somewhere here.
Will be like this.
Exactly. Correct? Correct? He's right. Thanks. So head is here. As you move in latitude, the head will keep, so angle will keep shifting till it comes here, and the head is here. So in Australia, do people stand upside down? No. How do they stand? Australia is here. They stand like this. The foot is always towards center of the earth. Head is always outside. So it's not like Australia, they stand upside down. In England, they walk horizontally. It's not like that, right? Clearly, foot is always towards center of the earth. Now, if I stand here, now or here, see here or here, which position is it pointing towards the sun? First or second position? First position, right? So here, so therefore, where will the sun be at midday? if it's pointing towards the sun, then at midday, so this point was here, sunrise, then no, 9 o'clock, 10 o'clock, 11 o'clock, at midday it's here. So sun is where? Directly overhead, because this is up, this is down, correct? Now for a person standing here, where is directly overhead? Which direction is directly overhead? Can you show me with your hand? Where do you think? This way. This is up. This is down. So directly overhead is this direction. The sun directly overhead? No. Sun is at the angle. Right? At what angle? This angle. Right? So some person is standing here. Then sun is this angle away from the up position or overhead position. Correct? So this corresponds to June solstice. June 21st. The sun is exactly overhead the equator. Sorry. So overhead this line. Sorry. Tropic of Cancer. Tropic of Cancer. Okay. That's why it's summer, northern hemisphere, because in June 21st, sun is exactly over Tropic of Cancer, which is, roughly around below Delhi, somewhere Rajasthan. And that's why it's hottest in Rajasthan in June, if not for the monsoon. Okay. Now, 6 months later, the Earth's axis will again be exactly same. It won't be like this, right? It will be same. So sun is here. So if the sun is the table, if the Earth is here, when it goes around, it will again be here. It won't be like this, right? It won't move that way, right? And therefore, in December, the opposite thing will happen, right? So for the equator, person standing at the equator, sun is not overhead. Up is here. So, and then for the third person standing at the Tropic of Capricorn, sun is overhead, right? So for Tropic of Capricorn, 23.5 degrees south latitude, sun is directly overhead at midday, which is why it's summer in the southern hemisphere and winter in the northern hemisphere. If the sun is directly overhead over Tropic of Capricorn, which is this, then if you're Tropic of Cancer, the sun is twice 23.5 degrees, right? 47 degrees away from the overhead position, and then sun is very, very low the horizon, therefore it's colder and it's winter. Correct? In between the two will be the equinox, where the sun will be overhead the equator. So equator, then it will be like this. Okay? So that is why the sun is not exactly overhead throughout the year. It's overhead Tropic of Cancer in June. It's overhead Tropic of Capricorn in December. It's overhead the equator in March equinox, September equinox, which means between them it has to travel. So the sun travels, sun's overhead position, its sun is overhead in Tropic of Capricorn in December, then January, February, March, April, May, February, March is overhead equator, then April, May, June is overhead Tropic of Cancer, then July, August, September is overhead equator, October, November, December is again overhead Tropic of Capricorn. Correct? So now, when is zero shadow day for people at 23.5 degrees south? In Australia, when is zero shadow day for Tropic of Capricorn latitudes? December 21st is zero shadow day for Tropic of Capricorn. When is the zero shadow day for Tropic of Cancer for Rajasthan? June 21st is zero shadow day for Tropic of Cancer. Now, when is the zero shadow day for the equator? March or September? March and September, it's above the horizon. It's overhead at midday. Therefore, equator has two zero shadow days. One on March 21st, other on September 23rd. For every location between the Tropic of Cancer and Capricorn, there will be two zero shadow days. One when the sun is moving from south to north, other when the sun is moving from north to south. At the extreme point, there will be one zero shadow day. Now, what do you call the sun moving from south to north in India? In the Indian system of astronomy, what do you call when the sun moves from south to north? The older people know. In your Panchang, what do you call when sun moves from south to north? Uttarayan. And when the sun moves from north to south? Dakshinayan. Have you all, the younger crowd, have you heard of Uttarayan, Dakshinayan? In connection to Sankranti and all that? Okay. So Sankranti is not aligned with Uttarayan for reasons which I will tell you later. But anyway. Therefore, So this is the same figure basis. Sun will be directly overhead on 21st June for locations on Tropic of Cancer, 20th December for location Tropic of Capricorn. These are zero shadow days for these latitudes. Okay. Now this we'll ignore. This also we'll ignore. Okay. Now if the sun is not directly overhead, okay, then it goes, then it's here, it's somewhere here, right? It also, because it doesn't follow the same, it doesn't go exactly the same location at midday every day. It also doesn't rise at east or west exactly every day for the same reason. So in summer, the sun will rise north of east. In winter, sun will rise south of east. So June 21st, sun will rise 23.5 degrees north of east. On December 21st, which is the winter, it will rise 20.5 degrees south of east. And on March 21st and September 23rd, where will it rise? Hey, come on. June 21st, it rises 23.5 degrees north of east. December 23rd, it rises 23.5 degrees south of east. September 23rd is the middle. Where will it be? Exactly east. Again, March 21st, exactly east. So same as the overhead thing, east and west, right? So June 21st, it will rise 20.5 degrees north of east. Then July, August, September, exactly east. That's equinox. Because rise exactly east, day and night are same duration. So equinox. Okay. Then October, November, December, 23.5 degrees south of east. It's coldest. It also goes very low in the horizon. Then January, February, March 21st, rise exactly east again. So equinox. Then April, May, June. Okay. That is why if you look at the first figure, this figure, the rise seen and set point goes from 23.5 north to 23.5 south of east over 1 year. Okay. And here in June, it rises north of east, right? Then July, August, September, it rises exactly east and sets exactly west. October, November, December, it rises south of east and sets south of west, right? And goes low in the horizon. And then January, February, March, it rises exactly east, sets exactly in the west. Okay. Now, but what happens to places north of Tropic of Cancer, south of Tropic of Capricorn? Will they have a zero shadow day? They can't, right? Because sun will never be directly overhead for latitudes north of Tropic of Cancer, south of Tropic of Capricorn. So zero shadow day occurs only in this belt between Tropic of Cancer and Tropic of Capricorn. So southern India below Ujjain or Bhopal or Indore will have zero shadow day down to Andaman, Nicobar, but then not above. Okay. So there cannot be a zero shadow day for north of Tropic of Cancer because 23.5 degrees is the maximum sun will go north of east, right? Now, and same way, there will be no zero shadow day for locations south of Tropic of Capricorn. Okay, right. Now there is the same figure expanded. Now the zero shadow day is for equator is March 21st, September 23rd. Let's look at the Uttarayan. So March 21st, June 21st, it has to be zero shadow day in Ujjain. So it has to go in between very fast, right? So these are the zero shadow days. Trivandrum, 13th April, 15th April, 17th April, 19, 21, 23, 25, etc. up to 21st June here. Then 3rd July, 8th July, 12th July, 15, 18, 21 July, 24, 1st August, 9th August, 17th August, 23rd August, etc. And then it will go to 23rd December, Tropic of Capricorn, and come back. So you see, every latitude will have a same zero shadow day, and it moves roughly around 100 kilometers. It moves by a day. So today is zero shadow day in Mysore. It's zero shadow day in Bangalore on 24th. So we're going to do the same exercise in Bangalore on Wednesday. Okay, but then it will be. But then if it is zero shadow day in Bangalore on Wednesday, it's also zero shadow day on 24th on Wednesday for Mangalore and Chennai. Why? Same latitude. Okay. So then, but then Hyderabad is 9th May. So it takes that long for the sun to be directly overhead in Hyderabad. Okay. And then on the way back, it's for Mysore, it's roughly 19th August, 18th, 19th August. But then usually we have monsoon. So Dakshinayan Shirashara Day we don't do in India except for Tamil Nadu because everywhere else is cloudy. Okay. Now, one more thing before we kind of wrap everything up. I said that the sun is directly overhead at midday, but midday is a very approximate. Is it overhead at 12? Or at least does it reach the highest point at 12? Now we know it's not directly overhead every day, but highest point it will reach. Does it reach the highest point at 12? We say midday is 12, but that's also not true. Okay, it can vary by around 40 minutes this way, that way. And that is because of something he said at the very end, which is that the Earth's orbit is not circular. You know that? Earth doesn't go around sun exact circle. It goes around sun in a squishy circle called the ellipse or oval. Okay, it's like an oval. Okay, because of that and because of the Earth's tilt, the highest point can will vary over the year. Okay, and so it varies by 20 minutes roughly this way, that. Okay, so today the local noon is at 12:23. It's not at 12. Okay, tomorrow it will be different, day after it will be different by a few seconds, and ultimately it will vary by 18 minutes plus or minus. So today at 12, so 12:23 it will be directly overhead, not at 12. Okay, now what happens? How do you measure how high the sun is? Now what happens if I give you a clue? The clue is you put a stick in the ground. A very, very sophisticated astronomy instrument is a stick in the ground. Vertical stick in the ground has been used for centuries in India, China, etc. to do astronomy. It's a very sophisticated instrument. Okay. Now, if you have a stick in the ground, what happens when the sun is somewhere? Well, what is the effect of the sun on a building or a stick or you? What happens? There's a shadow, right? The sun is here. Where is my shadow? Behind me. Sun is here. Where's my shadow? Left of me. So a shadow is opposite the sun. Now sun is very low in the horizon. How is my shadow? Very long. Right? Sun is very high in the horizon. My shadow is very short. Sun is directly overhead. My shadow is no shadow. Because shadow will fall under me. Right? Exactly under me. So that's a zero shadow day. Because if the sun is directly overhead, then a vertical object shadow will be under it. So there won't be any shadow. Sun is not overhead, there will be a shadow. So every other day at the highest point you will cast a shadow. But the higher the sun is, smaller the shadow. Right? Correct? Which is why sunrise shadow is very high, and then shadow is like very low. Shadow is very high, very long again at sunrise. Okay. Now forget sunrise to sunset, but look at highest point over the months. Now in winter sun is low, so the shadow is shorter or longer? Longer. In summer the sun is higher, so shadow is shorter. Now if I measure this, I can measure shadow length easily. Right? If I have a pole, I can measure shadow length easily. So shadow length is dependent on how high the sun is. If I can calculate how high the sun is just by measuring shadow length. Okay, that's why it's very important, right? So you can calculate so we're doing a telescope for it. People are doing it for centuries, right? So in Europe, it's called a gnomon, Gnomon. In India, it's called a, you know what the gnomon or a vertical stick is called in Indian astronomy? Shanku Yantra. If you want to be fancy, Shanku Yantra. If you don't want to be fancy, Shanku. Okay, so Shanku Yantra is there. So even in Jantar Mantar, etc., they are fancy versions of Shanku Yantra. Okay, so if you have a stick and its shadow, length of the shadow, if you know the height of the length of the shadow, you can calculate the angle made by the sun, which is the sun's height, elevation above the horizon. Okay, how many of you know trigonometry? Trigonometry? Hey, you all BSc, no? So you know trigonometry. Huh? How many of you know trigonometry? Put your hands up. You guys know or don't know? Have you learned trigonometry in high school? Have you? So put your hands up. How many of you learned trigonometry in school? Okay. So for those who haven't learned trigonometry, if I know how high the stick is and how long the shadow is, I can calculate the angle it makes. that angle is the height of the sun. For those who know trigonometry, if you calculate the ratio between the height and the length of the shadow, then what is it a function of this angle? Tan theta, right? So therefore I can calculate theta as tan inverse length of the height of the stick by length of the shadow, right? And then I can calculate this for every half an hour, every 5 minutes. I can calculate January, February, March, April, etc. By doing all this, that is how you found everything I told you before was measured using this method for centuries, everywhere around the world, not just India. Okay. Okay. Now, so what this does, Dongla is again zero longitude of India. Remember, this is there. So you have this. We'll do this upstairs now. Okay, there's a glass plate and there are these pipes. So the pipe will cast a shadow. It's a hollow pipe, so it will cast a shadow, right? As it gets to zero shadows, a shadow, you won't get a full exact circle because sun is not directly overhead. At zero shadow, exactly at local noon, at zero shadow moment, see now it's an exact circle. Okay, and then after zero shadow moment, 12:25 or so, again the sun will go this way, right? And then it won't cast an exact shadow or circle, but then it will be a ellipse like that. Right? Sun is here, then the shadow of the stick is just one whole a cylinder, right? Right? Do you understand why this is caused? So now using this, you can measure when zero shadow is, right? Let's do it again. Now you tell me from here when you think zero shadow was. What minute? I said roughly 25, but you tell me if you can make it, if you can get a better answer. Tell me at what minute it was zero shadow according to you. Zero shadow day moment according to you. Is everything set up upstairs? Sumukha? Is everything set up? You ready? Okay. Okay. How are you doing for time? Oh, okay. 11:20. So tell me when do you think is zero shadow moment? Well, 12, 25, 26, 27 roughly then. Yeah? Okay. So this is what we will do upstairs. Okay. So what you do is you have this, I have a flat piece of paper and a vertical stick, and then you plot the shadow every 5 minutes. Then you can see it becoming zero. You can also see how fast the shadow moves actually. Okay, like the one on the right side. Yeah, please. No, it will depend on the latitude and long. It will depend. It changes latitude and longitude because of the time zone and latitude across the same longitude. Same longitude it will be same longitude it will be the same. Yes. But then time zones, etc., which country you are on. Okay. So you see 11:30 the shadow was long, 11:44 shorter, and then 11:53, 11:58 it was zero shadow for this location. There's no shadow. Then the shadow starts appearing on the opposite direction. Okay. So we will do the same exercise on the right side. Okay. So like this. So you mark the zero. So you mark the shadow, and then this day was done. This was done on a day where it was not zero shadow day. So the shortest shadow is here. Okay. So it's not zero, but it was a finite short shadow. Now, the other thing you can do, the reason this is very important is historically, and even now you can do it, is that this was used to measure the Earth's diameter in 300 BC. Okay, 300 BC is 2,600 years ago in Alexandria in Egypt. Okay, there's an Egyptian astronomer called Eratosthenes. Okay, and he used the zero shadow day concept 2,600 years ago to calculate the Earth's diameter to within 2% error. That's pretty amazing, right? Now we have fancy GPS and all of that, but then you could measure it to few percent accuracy, 240 BC. So we'll see how you do that. Okay, well, I don't know which figure to. Okay, let's do this figure only. So he was in Alexandria Okay, and he had heard from someone there was a city called Sian. Okay, some 150, 200 kilometers away in Egypt. Okay, somebody had told him that in Sian on a particular day in the city called Sian there was a well, and somebody said that that if you stand at the bottom of the well, I don't know why somebody stood at the bottom of the well, somebody stood at the bottom of the well. Okay, and they said on this particular day sun was exactly overhead. Now why a well? Because then your field of view is very narrow, you can see whether the sun is exactly overhead or not. And then he got this bright idea. He said, okay, now that means on that day it was zero shadow day for Sian, which meant sun was exactly overhead. Then he said, okay, I will now at the same time it is exactly overhead that well in Sian, I will measure the length of the shadow in Alexandria. So the sun is, so if it's zero shadow day here, that means sun is in this direction, right? Which means sun is in this direction in the red direction in Alexandria, which means if there's a pole, that pole will cast a shadow, right? So this is the length of the shadow. Okay, so he measured the length of the shadow, measured this height, and therefore he could tell this angle alpha. This angle alpha he measured. Okay, this is cotangent theta. Okay, of this by this. So he measured this angle alpha. Now these two have to this is the top for Alexandria, top. So this is vertical. This is the vertical for Sian. Now if you join the extra two lines, they have to meet at the center of the earth. Right? That's how top is defined. Right? Now if this angle is alpha, which he measured by the length of the shadow, this angle is also the same angle. Therefore, the latitude difference between Sian and Alexandria, they are roughly same longitude, is alpha, which was 7 degrees, I think, for him. Okay. Now, what happens if I go 360 degrees from here? What happens? From here, if I go alpha, I come to Alexandria. If I go 360 degrees, where do I come? Back to Sian. Right? Now look at what, now if I have an angle here, it makes an arc on the surface of the earth. So from here, if I go 360 degrees, how long is that arc? It's the circumference of the earth. Right? So if I go 360 degrees from here, I go one full circumference. If I go only alpha from here, then I'll go to that fraction of the circumference. Now then he made the army of Egypt walk, okay, from here to here using standard paces. And then he told them to measure the distance, this arc between Alexandria and Sian, he made the army measure for him in 240 BC. So if this, he knew this was some length, he knew this alpha, he knew 360 degrees, then you can calculate what the equivalent arc is. That arc was circumference of the earth. From there you can measure the radius of the earth, because circumference and radius is 2 pi r, right? Therefore, and then he found the radius of the earth, which we now know is accurate to some 2 or 3%. This is very, very accurate. So we do this every year in India as well. So what we do is, 24th, what we're going to do is the same longitude as Bangalore is Bhopal. So at zero, when it is zero shadow moment in Bangalore, we're going to ask the students in Bhopal to measure the length of the shadow. We then use the Bhopal-Bangalore distance and we calculate radius of the earth. Okay. So we'll do the same thing. Bhopal said they'll give us the angle today at 12:23. If they do that, then we'll also calculate radius of the earth here. Okay. So that's the same thing, right? So in Sian, there's a well, and then the top points to the sun. Here it doesn't point, therefore there's a shadow. And then this was 1/50th of a circle, which is that angle 7 degrees, is 800 kilometers measured in the units Egypt used in that time. And therefore the full circle is this, which is 40,000 kilometers. You divide by 2 pi, you get the correct answer, roughly 6,500. Okay? Right. So what should we do today? We may not do. We'll show you the sunspots of the sun, but safely. You should never look at the sun through any telescope. Don't look at the sun directly. Don't look at the sun through binoculars. Don't look at the sun through telescopes. What happens? What happens if you look at the sun through a telescope? You'll go blind. Why? Have you burnt a piece of paper with a magnifying glass? All of you done that. So magnifying glass is this small, and then it burns the paper because it focuses the light on a very small point. It's hot enough to burn paper. A telescope is much more powerful than a magnifying glass. What's in the focus? Your eye. So what will happen to your eye? It will melt. Okay, so you should never look at the sun through any optics or even directly. So we will show you the sun's image in a safe way. Then we'll also measure the shadow every 5 minutes. Okay. Now there's a video which can explains everything I said. So we'll also go through this. Can you hear? Everything I said? Correct? You know why now. Five minutes. 5 minutes. It's clear. It's clear. This was made for Pune, which is 18.5 latitude. Okay, this kind of summarizes everything we learned so far. Okay, that's it. So we're done now. We'll do a few questions for 5 minutes and we'll go on. Okay. We can also discuss upstairs while you're doing things. We'll understand better when you're doing it upstairs. But we can have a few questions now. That is random. So each planet has its own axis of own angle. So for example, Mars I think, is also very similar. Mercury is almost 0. Venus is, I think, 10 or 12. I think Uranus is almost 90 degrees. It's flipped 90 degrees.
What exactly is the reason for that?
So when the planet formed, so it's about how it formed. It's about how it formed. Okay, and when it formed, how did the gas which formed the planet rotate? Also, when long back, when the planets' orbits were different from where they are now, when two planets kind of come closer together, the mutual gravity will also change its direction of axis. So that initial formation plus interaction between the planets will also change its axis. So Uranus' axis is 90 degrees almost. That is believed to be because it went close to Jupiter, and Jupiter then it did that too because of the gravity. Angular momentum changed, direction changed. So that is from the beginning. Okay, good question. So the moon's axis, moon's orbit around the Earth and the Earth's orbit around the sun are not at the same plane. It's inclined at 5 degrees. Okay, so the Earth's axis around Earth's orbit around the sun is like this. The Earth is here. The moon's orbit is like this. It's not like this. It's like this. It's 5 degrees. Okay, the moon's diameter is half a degree. So its inclination is 10 times its own diameter, which is why every full moon and new moon you don't get an eclipse. Okay, if this 5 degrees was 0, then every new moon and full moon you will have an eclipse. Other questions? Okay, a good question. So, so the axis is pointing towards the pole star currently, and sun is here. It goes like this. Okay, this axis actually makes a cone like this. Okay, so now it's pointing towards pole star. Later it will point towards other stars, and then it will make a cone and it'll come back to the same position. That is 28,000 years. Okay, this motion is called precession. It's like if you have a top and you spin the top, it will go like this and it will go like that and it will go like that. Same principle. Okay, it's because of the sun, and that is called precession. But that's 28,000 years. So you'll only see the difference of few degrees after 200 years. But then therefore every 50 years we change our tables, right? And it's called precession correction. In the Indian system, it's called the Ayanamsha. Okay, and so you have to correct for it periodically. But it's still 23.5 to the vertical. So if the angle is 23.5, the direction keeps changing every 28,000 years. But then 23.5 itself varies a little bit by plus or minus 0.2 degrees. Okay, that's called nutation. But that's a very small correction. That's even longer. Okay. So for till we die, it's 23.5. Okay, that you can assume. But for example, when Aryabhatta observed the night sky, and he made his tables for the eclipses, the Earth's axis pointing somewhere very far away. Okay, pointing some 40 degrees away from the pole star. Therefore, if you take his tables and apply it and predict eclipses now, you'll get it completely wrong. Because you have to apply the correction for the precision for the intervening 1,400 years. Right? So then every 50 years, 100 years, you have to apply correction. So if you don't do that, and that is a difference. So that is a difference between. So the calculation part of astrology, the predictive part is just pseudoscience. There's nothing in it. It's all false. But the calculation part of astrology is same as astronomy, except that many astrologers don't agree to include the precision correction, which is why Uttarayan and Sankranti are 3 weeks away, because they refuse to apply the correction. So they say Uttarayan starts on Sankranti, which is Jan 15th. It doesn't. Uttarayan starts on December 22nd. And this 3-week difference is because they do not apply the precision correction. But the Indian astronomy traditions, they apply the precision correction. So if you apply the Ayanamsha, so they have two systems. One is applying without applying. With application, you get the correct answer, matching today's observations. Okay, so the Indian astronomy system traditionally do that. The astrologers don't do that, and then they're off by 3 weeks. Okay, same way with the Western astrologers also, they're off by 3 weeks. So they say your star sign is something, it's actually one zodiac before. They're all wrong. Okay. If you apply this correction, then you get it correct. Okay. So Jan 15th, Makara Sankranti mane, it goes into the Makara constellation, but then it's not Uttarayan. Uttarayan started 3 weeks before that, which you can verify yourself. All you have to do is to go see sunrise, sunset, and around December, January, you notice which date is the sun rising the north, southernmost from east. You'll notice it's December 22nd, it's not Jan 15th. So you can do it yourself, right? And convince your grandparents that they're wrong. Okay, let's close, we'll go upstairs and now we will do experiments ourselves. All of you have to measure things, none of you can stand and watch. And then while doing things, you will know yourself as to how things work. Okay, come.
Just
It's done. I mean, I showed the QR code for the WhatsApp. You mean the, okay, fine. Yeah, go ahead. We'll have to remove this now because when you come back, they might lock all this.
announce the break. Okay. So I hope you all had a experience talk. So next part of this is, as we mentioned, hands-on experiments, so hands-on session and demonstration. Before that, we will take a 10-minute break. We have some refreshment and the hands-on session will be in the terrace. We will be guiding you to the terrace.
But the special also is terrace, right?
The refreshments are also in the terrace. Before that, I just wanted to draw your attention to our social media accounts. Importantly, all our talks, for example, today's talk will also come on YouTube. And we are actively there on Facebook and Twitter. And Spotify, we are doing the weekly radio program with the radio rooms of the University of Mysuru. It is called Nakshatra. Every week, if you are there in Mysuru, you can install Radio Moon's app, and every Monday you can tune into an astronomy radio program.
And a lot of them are in Kannada.
Yeah, a lot of them. Most
podcasts are in Kannada. A lot of the posters on social media are in Kannada and English. Okay.
So that's why we want you to follow our Instagram, Twitter, and Facebook, and also YouTube. But if you go to Spotify and just type Cosmos Mysuru or Cosmos-EPOC, or our podcast name is Nakshatravani. If you type that, you get all our previous episodes, which was aired on Radio Manasa. So if you miss out the episode on Mondays, you can listen to them on Spotify.
Have you all heard of Radio Manasa? It's the radio channel of the University of Mysore.
Okay. So you can install a Play Store app. It's called Radio Manasa. But if you miss out the radio episodes, you can listen to the same episode interviews and the recent updates and many more interesting stuff on our podcast. You have to install the podcast. Or you can also access that.
Yeah.
So now we will go for the break. Now we are going to the terrace. We'll have 10 minutes of break for the refreshments, and then we'll move.
Where are the restrooms and drinking water filling up?
Yeah. If you go out from this door, the restrooms are on this side, and the drinking water is the other side. There's another auditorium towards that side.
It will be very hot, so please drink a lot of water. You will get dehydrated. It will be very hot because sun is directly overhead. Okay.
Yeah, and that's why we are giving you Nimbu juice.
Yeah.
Before the election. Yeah, thank you. So now we'll go to the terrace.
I kept my glasses somewhere. Okay. And my phone. Oh. Your mouse, take it, else it will go away. A globe we have to take back, pen you have to take